Alright, so this morning we are working on lesson 1.3. Our lesson is over prime factorization. How many people kind of remember what prime factorization is? Good. Okay, not that many, but that's okay. Actually, prime factorization I think is really simple if I know my math facts. If I'm not very good knowing my math facts, like what numbers go into 54, and I can say 6 and 9. Well, if I can't do that, that makes it a little more tricky. But I will show you ways that we can use a calculator to help us, as well as that multiplication chart I gave you. But I thought I'd just give you the answer. Remember, we don't want to use our calculator or other things to just give us the answer. We're only using those to help us. They're a tool to help us with some of the calculation. So, here's what we're going to look at. Prime factorization. Today's goal is I will write a number as a product of prime factors and represent the product using exponents. Once again, that's probably something like, okay, I don't know what I'm supposed to be able to do. But mainly what I want us to be able to do today is if I give you the number 12, you're going to write it out as prime factors using the prime factorization tree. Like maybe I do 2 times 6, and then 6 is 2 times 3, which we would write as 2 times 2 times 3, which breaks down to equaling as 2 squared times 3. Okay? That is what you are going to be able to do today. Now, some of you might have seen this before. Some of you might be looking at it and be like, whoa, I don't know. But just kind of look. I'll pause a second. I want you to look and see what I did and see if it makes sense to you before I even explain anything. So I had 12. I did 2 times 6. And then I broke 6 up to 2 times 3. Okay, the way we are going to be getting that today is first, we have to be able to find factor pairs of a number. And this is going to be key vocabulary work. We're going to work on this on example 1. Then we have to know what prime and composite mean. Remember we had about 2 of those questions on your homework the other night? We'll discuss what prime and composite are. We're going to create a factor tree to find the prime numbers. And then we're going to write the prime factorization of a number. So we really have it broken up to 4 parts, and they all end up working together. Alright, what I want you to do first is our exploration. Remember, exploration, if we're doing right, you are really talking. It's early in the morning, I know. You guys don't want to just sit in class, so this is where you get to turn and work with partners. So, lesson 1.3, they still have our learning target and success written. Here's what you're going to do in exploration 1 in your table group. This is where I'll give links bucks out for groups I see you doing amazing. It says, work with a partner. You were working with your table group. 2 students use factor trees to write 108 as a product of factors as shown below. So student A said 108, student B 108, and they went down and broke it down by multiplication in different methods. On A, without using 1 as a factor, so I can't use 1. I don't say 1 times anything. Can you write 108 as a product with more factors than each of the students used? So right now, student A, when he broke it down, he got down to 1, 2, 3 factors. Student B made it 1, 2, 3, 4 factors. I'm just going to show you something. If I did 2 times 2, that's 4. And 4 times 27, I'm going to show the board on work over here. Gives me 108. On student B, if I did 3 times 3, that's 9. 9 times 2 is 18. 18 times 6 is 108. So if you're seeing what they're doing, they're breaking into a lot of smaller numbers. Student A made it 3 factors. Student B broke it down to 4 factors. With your group, can you find a way to make it more than 4 factors? Okay. I want your group to find that answer and then raise their hand. Because yes, you can. Okay? Only work on A right now. Ready? Begin. I forgot it needed to be on sphere for me to see this on the recording. Alright, so you were supposed to break this one down. So I have one group that started to get it, but they're still confused, but that's okay because I haven't taught this. This is supposed to be you trying to figure this out. So pay attention and see what we can do. Braden, what did you do? How did you break this up? So hold on, 2 times 54, and then 2 times 27, okay?
And then 9 times 3 to get 27.
So then we broke 27 into 9 times 3.
And then I put 3 times 3 to break up 9.
We broke 9 up to 3 times 3. Now, I will say the only thing to help is when you get to the end and you're done breaking a number out, you'll see we'll do this today, is I draw a box around it. That way I can easily see where my numbers are. Now, if Braden was to write out his multiplication problem, we would write 2 times 2 times 3 times 3 times 3. How many factors did Braden break it down to? 5 factors. What's a factor again? We did this the other day on lesson 1. What's a factor? Marley? Yeah, a number that goes into another number. So, all these numbers, if I was to go ahead, and I'll even use a calculator and show you guys in front here. Put it right here. If I do what Braden did, 2 times 2 times 3 times 3 times 3 equals, we get 108. Now, do you think we can break this down more than 5 factors? This is going to be the lowest we can go. Can anyone tell me why? If I look at my factors are 2, 2, 3, 3, 3. Why can I not break this down any more? Braden?
Because you can't use 1 as a factor.
You can't use 1 as a factor?
You can't break up 3 or 2.
Good. I can't break up 2 or 3. Do you know what that means? You know what that's called? Those are called, Marley? These are prime numbers. Our goal today is going to be when we break this down, we break it down to a prime number. If we looked up here, 2 was prime. 2 was prime. Was 27 prime? No, 27 is a composite number. Even if I label this so I know it, this was a composite number. Composite numbers have factors besides 1 in itself. A prime number, the only factors are the number 1 and the number itself. A composite has other factors. That is what we are going to work on today. Identifying factors. Ooh, I have to do this because Braden did it. This is the step I wanted you to do. Braden went ahead of where I asked. I told him he had to write down the 3 times 3 times 3. And he goes, can't I just write 3 to the 3rd power? Well, is 3 times 3 times 3, is that 3 to the 3rd? Yeah. My base is my repeated and a factor. It was used 3 times. What about 2 times 2 then? This is how you write prime factorization. If I asked for the prime factorization of 108, you would say 2 to the 2nd times 3 to the 3rd. It just happened that the 2's matched up and the 3's matched up. It doesn't always. We will get to that. So, right now, some of you should be like, yeah, I don't get what we're doing. And that's okay. We're getting into it. It's kind of exposing us to it. Let's see just one of these. Let's see if you can do the same thing. Let's do an easier one with the number 80. Okay? Let's only work on the number 80. I want you to make the prime factorization that we just did, break it down using the number 80 with your table group. Okay? You give we're back. Guys, you just impressed me for telling me you didn't really get this. You guys went with this one and ran from it right away. So, I want to see 80. One person tell me, how did you break it down? Alright, Stella?
We broke it down into 5. We did,
Well, what's the first thing you broke 80 down to? 40 times what? 2. Okay, 40 times 2. Then what'd you do?
Then we did 20 times 2.
Broke 40 down to 20 times 2. Did you break this 2 down anymore?
Yeah.
Huh?
No.
So I'm going to box it. Okay, then what'd you do?
Broke 20 into 10 times 2.
10 times 2. There's the 2 again.
And then broke 10 into 5 times 2.
Can I break the 5 down any? Because it is a prime number. So what was your multiplication at the end? 2 times 2 times 2 times 2 times 5. I love it. I heard someone start saying, well, that's 2 to the 4th times 5. Did anyone, I'm going to tell you right now, Stella's got this correct. She has the right answer. Does anyone have it different, though?
I have it different, but I got the same answer.
What? Say that real loud, because I want the recording to catch it. I want everyone in the class to say it loud.
I used a different, I broke it up into different numbers, but I got the same exact answer.
Okay? I don't believe you. I need you to prove it to me.
I broke 80 into 40 times 2.
Into what?
40 times 2.
40 times 2.
And then I broke 40 into 10 times 4.
Oh, there's a difference. Yeah, she did 20 times 2 and you did 40 times 2. Alright, let's see.
And I broke 4 off of 2 times 2.
And those are boxes.
And I broke 10 off into 5 times 2.
1, 2, 3, 4. So 2 to the 4th times. Oh. Alright, so there's only 2 ways to do this, correct? Did anyone do it different? Marley? Did you guys do yours a little different? Was anything broke up different?
8 times 10.
Okay, so you did 80. 8 times 10.
And then I used for the 8, it was 2. Yeah, 2 times 4.
2 times 4, there's that 2.
And then go down to the 4 again, which is 2 times 2.
Bless you, bless you.
And then if you go to the 10, it goes 2 to 5.
1, 2, 3, 4 2s. And a 5. Bless you again. There's another way I could break it down. I could have broke 80 into 5 and 16. Then I break 16 into 4 and 4. Each 4s go to 2 and 2 and 2 and 2. I would get the same answer. So we're already discussing C right now. Comparing they're different ways to get your answer. The biggest thing that we have to do is we just have to continually take each factor and say, is it prime or composite? I think to help you guys, I'll make a poster here this week, and we'll list our prime numbers. I'm going to write them on the board right now so you guys can use them as a guide to break them down. But our prime numbers, we're not using the number 1. We're going to use the numbers 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. We'll stop there for right now. To be honest, for your work today, you'll probably get down to the biggest prime numbers, 7 or 11. I put a star by the number 2. Can anyone tell me why 2 as a prime number is very, very special? Why? Why is 2 the only even number? Why isn't 56? Awesome. That was a perfect explanation. As 2 times anything will give me another even number. The only reason 2 is because it's the first even number. Alright. Amazing job, guys. Alright. Why don't you close these? Put them to the side. We'll put them away in a little bit. But let's look at our assignment today. Alright. Notes can go out in front of you. Name on your notes. Today's not work blocked yet. Wish it was 4 o'clock. Today is the last day of the week at school. It's a Friday. No school Monday. Alright. First thing, we have to look at, we have one vocabulary word we're going to focus on today. Even though I kind of don't agree with that because I think prime, composite, factorization, prime factorization, I think those all be ones. But they say factor pair. So, in your notes, you should have this. I'd highlight or circle. Remember, there's highlighters in your bin things if you need it. But it says, finding factor pairs. The brass section of a marching band has 30 members. The band director arranges the brass section in rows. Each row has the same number of members. How many arrangements are there? Now, biggest thing is we have to figure out what is a factor pair. Turn and talk with your neighbor for 30 seconds. If anyone think of what it might mean, break down the word. What do you think factor pairs might mean? Turn and talk. Alright, anyone have an idea? Coming together, anyone? Big idea? Braden?
Also, like factor pair is like a number times a number equals the one big number, like 9 times 2 is a factor pair for 18.
Awesome. So if I'm looking at a given number, I'm looking for what 2 numbers go together to give me that number. That's pretty spot on. I'm going to show you how we could ever find these. If I would go into our big ideas, and I'm in lesson 1.3, I'm at our example 1, you'll see some of these words. Here's factor pair on our Big Ideas website. If you click on it, it takes us to the glossary. A set of 2 non-zero factors whose product results in a definite answer. Exactly what Braden just explained. 2 numbers that when multiplied give us our given number. So, that's what we're going to be working at. So here's what they did. They said, we need to find all the arrangements of 30. So they said we need to find all the factor pairs of 30. So they said, well, we could do 1 times 30. So there could be one row, just like one row, and put 30 kids in a straight line. There could be 2 rows and have 15. There could be 3 rows of 10 and 5 rows of 6. Then they started showing that the 6 times 5, because what they're doing is they're finding like the opposite. Because remember, if I was to do one row of 15 this way, and say I have one row of 15 people in there, or 30, I'm sorry, I don't normally 15, 30, one row of 30, couldn't I say, okay, well, I'm only going to put one person here, but I'm going to do 30 rows, right? You're just doing the opposites. So if you find one factor pair, it gives you 2 solutions. I can easily say, if I want to do the number 6, and I said 2 times 3, well, 3 times 2 is also 1. Because I could say 1, 2, 3. Okay, I have 2 rows of 3. Or I could have said, hey, I'm going to have 3 rows of 2. All we're doing is turning them. Now, to help you find factors, I always taught my students, maybe your teachers did, they might have did the rainbow. I always call it the upside down rainbow just because I like writing that way. If we did 30, that's the number I need. Here's the easiest way I have found for anyone that's not good with their multiplication. 1, you can use that multiplication chart to help you. Get out that paper, and you're going to use that. But you always start with 1 and the number itself. We always know that has to be a factor, right? 1 times the number. So when I write that down, I connect them. 1 times 30. You see how I spaced them out? Okay, if I was counting, what comes after the number 1? Pretty easy question. What comes after 1?
2.
Okay, does 2 go into 30? If I wasn't good with my multiplication or division, you can get out your chart and go to 2 and go down. Does it go into 30? Or you can use a calculator and go 30 divided by 2. It does. How many times does 2 go into 30? 2 times
15.
So then 15 goes on the other side. And this makes a connection. After the number 2 comes the number 3. Does 3 go into 30? 3 times what?
10.
So then I put 10 on the other side. And they connect. Does 4 comes after 3. Does 4 go into 30? No. So I don't write it down. Does 5 go into 30? 5 times. Okay. After the number 5 comes the number 6. Oh, we already got it written down. Once I've written it down, that means that's a halfway point. I'm done. I have them all. Now, if my question asks me what are the factor pairs, I just have to say which ones are connected. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Alright, so here's what I want us to do. We're going to try this. On number 1, 18. On the side, in your notes somewhere, can we find the factor pairs of 18? I'm going to pause real quick. Go ahead. Try and find the factor pairs of 18. Alright, so let's start talking because the code, we're still a little confused. Some are getting it, some are just iffy. That's why we do a couple examples. All our goal right now is to list all the factors of 18. All the numbers that go into 18. The reason we do it this way, though, is if we were to just randomly guess, okay, does 7, does 5, does 8, does 9, and I'm just randomly guessing numbers, I never know if I have them all. If we do it organized, we really don't have to check that many numbers. I've done this with my students in the past, and we did big numbers, and they found out, like, even when we did 100, the most we had to go to was 10 numbers we had to check. For a big number of 100, the most we had to go to was 10. So, when we do this, 18, we're only going to have, like 4 numbers, 5 numbers we have to check. So, let's show how. All we do is we try and find what numbers multiply times each other. We already said 1 times 18. What's the next number to check, Marley? Good. 2 times 9. Okay. What's the next number to check? Cool. 3. 3 does go into 18 because 3 times 6. After 3, we would check the number 4. 4 doesn't go into 18. After 4, we check 5. Does 5 go into 18?
No.
After 5, we check.
6.
Oh, we already did 6. Since we already did it, we're done. These are all the factors of 18. And if they ask me for the factor pairs, it's 1 and 18, 2 and 9, and 3 and 6. Remember, pairs. Which 2 numbers go together? Okay? Let's try one more. Let's do 24. Ooh, we always played a game with infinity ball. We called it factor ball. So factor ball, the way we played it, was one person shouted out the next factor, and the person had to say what was its pair, and we had to go in order. So like if we did 18, I'd say 1, and I'd throw it, and someone would have to go 18, and then they toss the next person would go 2. Next person had to say 9, 3, 6. And the last person, if you catch it, they're all done, you say factor. If you call a number that's not one of the factors, or you've missed factor, you have to sit down. Let's try that on 24. So, stand up. Infinity ball.
Oh no.
Alright.
You said we'll call
So we're going to take this easy. We'll kind of do it together. Maybe we'll do it on another one.
Wait,
Alright, so I need the factors of 24, and we have to go in order. So the first person's going to say which number. And then when they toss, the person has to say, what times 1 gives me 24. Okay? So, let's try.
3.
Oh, hold on. What's the first one?
1.
So I'm going to write it up here to help us. 1. Yep.
8.
Nope.
24.
There you go. So 1 to 24. What's the next factor after 1? 2 is a factor of 24. 2 times?
9.
No.
We're doing 24.
Oh, yeah, it's 24. Sorry. 12.
Okay, good. 2 times 12. What's the next factor after 2?
Got it. Yeah. So 6 times 4.
Oop, there's one before there. We have to go 1, 2. Does 3 go to 24? So you would say 3. You toss it?
6.
Nope. 3 times.
Oh, yeah. 3 times 4. No, that's 12.
Can you erase the 18? Because everybody's looking at the 18. Everything is 18.
8.
3 times 8. Grab it, Lauren. Okay, so we've done 1, 2, 3, 4 is a factor. Toss the ball. Who has the pair with 4? 4 4 times. Well, we did 1 to 24, 2 to 12, 3 to 8, 4 times. No, what times 4 gives me 24? Sure, I'll take it. 4 times 6. If I toss to Hudson,
6.
we already did 6. Now, the next number is 5. Is 5 a factor of 24?
No.
The next number would be 6, but we already have it. So you would say factor, and we'd be done. All right, have a seat. We will play this game again, and we'll get better at it. But it gets you up and moving. This
I thought we were just like doing
This is our factor pairs. The way we do factor pairs is we just list them in order, and where is this? I'm going to show you. And if you are a person that is struggling right now with your multiplication facts, this is how we use our multiplication table. What number were we working on? 24? So I know 1 times 24 is going to be 24. If I look at 2, I just go, does 2 go to 24? There's 24. So I'd say 2 times 12. If I go to 3, because that's next, there's 24. 3 times 8. So 3 is a factor with 8. 4, there's 24. 4 and 6 are factor pairs. 5. Oh, there's 20, there's 25. 24 is in between the two, so is 5 a factor? No. We go to 6. Oh, we already did 6. We said 4 times 6. So I'm done. That is how you can use this to help you. Did I have to check all these numbers over here? No. We just go, and if you go in order, you go until you match up. All right. We're going to stop on that part. We're going to try this part, which is supposed to be harder, but I feel like you guys do better with this. So, this one is writing prime factorization. Writing a prime factorization of 48. They already did the work for us. Okay? Now, it shows us this is called a factor tree. What we did, this is what you guys did in your exploration, you did great with it, is you start with the composite number. Remember, composite is a number with factors other than 1 in itself. You can break it down. Prime only has 1 in itself. On this one, they said 1, oops, I can't even read numbers. They said 2 times 24, and this is a great trick. When you get to a prime number and you cannot break it down, circle it. That way you know you're going with it. I can break 24 down to 2 and 12. There's my 2. I can break 12 down to 4 and 3. 3 is prime. I can break 4 down to 2 and 2. Then, when you write it out,
I need Hudson Blacksburg to the office, please.
yes ma'am.
Thank you.
Then I just take this and I can write it down. There's one thing I don't like what they did. Right here, they kind of made a mistake. They wrote 2 times 2 times 3 times 2 times 2. One rule in math that you should do is you should put it in order. At the very least, it should have been 2 times 2 times 2 times 2 times 3. Your smallest numbers come first. And then because you guys are geniuses and you were already a step ahead of me, if I was to write this out, just like they did here, I had 4 2's. So I'd write 2 to the 4th, and I still times it by 3. Okay? If you look at factor tree number 2, they did it different. They did 3 times 16. 16 becomes 2 and 8. 8 becomes 4 and 2. 4 becomes 2 and 2. But they get the exact same answer. If I keep doing this, there's multiple ways to do this. Like when I did the very first one, 2 times 24. There's 2. They made 24, 2, and 12. Well, I could have done 4 times 6. And then 4 became 2 times 2. And 6 would become 2 times 3. And we still get the same answer. 2 times 2 times 2 times 2 times 3. There are multiple answers, multiple ways to get to your answer. That's the cool thing, whatever you're most comfortable with. So, I want you guys to try this. Let's do number 5. Try and come up with your factor tree for the number 20. Go ahead and break it down all the way and we'll compare our answers. Alright, so let's look at this real quick. A few of you went and did the other ones, and that's cool. We're going to look at all of them quickly. So, there's multiple ways. So watch the way. The main thing is check to see if you have the same answer. So, what did someone do to break down 20? Marley, what'd you do?
5 and 4.
Okay.
And then 4 I did 2 2.
Okay. Now, the only thing is, I would write the numbers out as either 2 times 2 times 5 or 2 squared times 5. Perfect. Good job. How about, did anyone do 88?
I never.
That's okay. I saw a lot of people going through them. All right, what'd you do for 88? If you did, follow along.
I did 11. 8.
Okay?
And then for the 8, I did 4. And then I did 2.
And 11 is prime. So what would be your final answer? How do we write out the multiplication?
2 times 3 times 2 times 11. And 2 to the 3rd power.
Good. I believe on your homework you're allowed to write it out as 2 times 2 times 2 times 11. I believe it's taken that way on your homework. Awesome. Great job. Can I give you guys a hint when you're doing this? The number one thing I've always seen my students do is they do the one number they know for sure. They go 2, and they do a small number. And that works, but if you can use the larger numbers, it also helps. It helps break it down so you're not looking at other big numbers. I'll show you why on number 8. How about 90? Did anyone be able to break down 90? What you got? Dylan?
I did 9 and 10.
Okay, 9 times 10.
And then I did break down 9 3 times 3.
And those are primes, so we circle them.
And then I did for 10 2 times 5.
And those are both primes. So we'd be left with 2 times 3 times 3 times 5, or 2 times 3 squared times 5. Okay, the hard one. I'm going to scroll over some. 462. Now, this is where, if you use the small number, which, to be honest, is probably what I would have done, I would have started with the number 2. So if I do 2, I get 231. And that looks like a prime number, especially because I know 31 is a prime number. However, if I try finding some other numbers, what I would do is I'd use my calculator, and I would have done 231, and I know it's not even, so it's not 2, and I divide by 3. I would check 3, 4, 5, and I'd just start working my way down for a while. If I divide by 3, though, I get 77. 3 is prime. 77 breaks up to 7 times 11. 7 is. 11 is. So this became 2 times 3 times 7 times 11. Now, I tried on your homework when I chose the ones I want you doing. I want you to work on this concept. So I tried to choose common numbers that, to be honest, are ones I saw in real life. But you might have a couple big ones to challenge yourself. Okay? One last thing to look at. Before I go on, why don't you guys just give me fist in front of your chest? I need to know, how do you feel with doing prime factorization? Now, I'm going to ask you this twice, because there's 2 parts of this. One, do you understand how to do it? Not can I do it because of the multiplication. Just first, do you get the steps, what you're supposed to do? So, thumbs up, I get the steps. Maybe I'm struggling with it, but I get the steps. I don't really get the steps, or I have no idea what we're doing. Go ahead and do that. Fist in front of you. Just about the steps. Just about the steps. Okay, now let's do it again. Let's do it again. Second time. Not about the steps. This one is, how do you feel actually doing it because of the math? The math. Is the numbers, the multiplication, find the factors, is that what's holding it? Thumbs up. I got it. I got good strategies. Sideways, it's pretty difficult for me. Thumbs down, it's really hard for me.
No.
Alright, good. Okay, let's move on. I know a couple people I just want to talk with, but here's the last thing. And I notice we have all this. We're not going to look at all that. Writing the prime factorization of a number, this number 3, I'm going to take a shortcut on that to help you guys. We've actually, it's because part of this came down. That's why. We've actually done this with writing prime factorization. That is this part right here. But this part, somehow my notes got mixed up. They just scrolled down. But using a prime factorization, there's a different question they're going to ask you. And it says, what is the greatest perfect square? This part's a little tricky. Okay? Now, the way we do this, because 1,575 has many factors, it's not efficient to list all of its factors and to check for perfect squares. Use a factor tree to write the prime factorization of 1,575. So they did the factor tree here. We're going to just start there before I talk more. We did 25 times 63. 25 broke into 5 times 5. Those are primes. 63 to 7 times 9. 7's prime. 9 to 3 times 3. And those are prime. And they wrote out that part. You should be able to do that. That just would have been hard because that's a big number, right? But they did prime factorization tree. Nothing new. We already did those. However, it says the prime factorization shows that 1,575 has 3 factors other than 1. Yeah, we have the numbers 3, the number 5, and the number 7. Now, 3 times 3 was 9. If I did 5 times 5, I got 25. And then what they did was they kind of times them together. Now I could do this two ways. I could just do 9 times 25 and get 225. Or what they did was they realized that these 3 and 5 and 3 and 5, they have to be a pair that's the same. 3 times 5 is 15, 3 times 5 is 15, and 15 times 15 is 225. This is hard.
Yeah.
Okay? Trust me. I think we only tried one example or something on your homework. But when they ask for a perfect square, remember, perfect squares, we did those in lesson 1. What is a perfect square when they have two numbers that times by itself to give you that number? 9 is a perfect square because 3 times 3 equals 9. 16 is a perfect square because of 4 times 4 equals 16. 25 is 5 times 5 is 25. Okay? With a big number, if you list all the factors out, I will say the easiest way is to look for which one has 2 of them. There's 2 3s. There's 2 5s. What I would do is just multiply all those numbers. I'd go on my calculator, and you would say 3 times 3 times 5 times 5 is 225. The reason I did not include the 7 is because 7 didn't have a second 7. We only include it if it has one that's the same. So, if I scroll up to our previous homework, on 88, it asks, what is its perfect square? Well, we have 2 times 2 times 2 times 11. I would see 2 times 2. That could be a pair. Does this 2 have a partner? No. Does the 11 have a partner?
No.
No. So 2 times 2 is 4. The greatest perfect square of that one is 4. Okay? We're going to try this today. We'll see where you guys are at. I think there's only 1 or 2 in your homework. But I want you to get started. So, what we're going to do is we're going to put our stuff to the side. Oops, I probably need to turn to this. Yep. Alright. I would put my heading on here. When you get your blank paper, we can get you some in a second. You need to put your name, the date, today's lessons, chapter 1, lesson 3. The assignment, or the last thing I wrote is, some other groups got me to start doing this. If you guys would put 1P on the 4th line, that just lets me know that you are the first group purple. Okay? Yep. First group purple. Alright, what I need you to do, open up Big Ideas. Where do your notes go, by the way?
Your binder.
Good. Notes go in your Avid binder. Your workbook goes back in the black tray. And you can get started on Big Ideas.